In the last series of lectures, we considered the question, what is a patient? That naturally then prompts the question, well, what is a disease? We offer classifications of disease that are based on evolutionary and mechanistic causation. We do not see disease as being simply infectious or chronic or degenerative. We see disease as having a finer, more nuanced kind of a structure that relates both to its evolutionary origins and to the kind of mechanisms that mediate its impact. So these 7 categories of disease are actually going to help us analyze defenses, maintenance, and vulnerability. The concepts are set up to connect to each other. The first point to make is that the risk of disease varies with both genotype and with environment. The way that this graph is set up, the x-axis is just an array of genotypes. The y-axis is the risk of disease going from low to high. And every point on the red line represents a genotype and an associated disease risk. And if you look across that, it's a rather complex, we've deliberately sketched a rather complex case. Environment D poses a risk of disease for almost all genotypes because virtually every point on the line is above it. So there's some risk of disease in environment D for all of these genotypes. But if we look at environment A, it is posing a risk of disease only for those genotypes that are above that dashed line there. All of the other genotypes are not at risk. And this is a general picture. This is something like this could be sketched for any real case, for any real disease. So here are the 7 categories. And this deliberately recognizes that the causation of disease is complex. And at the outset, I should say that some diseases belong to more than one category, and when that happens, it indicates that they have complex causes. So category 1 diseases are diseases with genetic causes. Category 2, diseases with environmental causes. Category 3, diseases that are byproducts of defense systems. Category 4 are diseases of homeostasis. Category 5, diseases that are caused by lack of maintenance. Category 6, diseases caused by stochastic developmental problems. And category 7 are diseases of pregnancy and early development that are caused by maternal-fetal and maternal-paternal conflict. So this is one of the more evolutionary of the causes, as are the genetic causes. So diseases that belong to more than one category have multiple causes. And an example is type 2 diabetes. It is a disease both of homeostasis and of maintenance. So, category 1, genetic causation. Genetic diseases are usually caused by mutations to single genes. They cause disease in any environment, and they are often lethal, or if they're not lethal, they prevent reproduction. An example might be trisomy 21. Here is trisomy 21, 3 copies of the 21st chromosome. Cystic fibrosis, severe combined immunodeficiency, and thalassemia. No specific mechanisms have evolved to protect us against these. Their prevalence is increasing slightly as medical progress rescues cases that were previously lethal. Category 2, environmental causation. So as leading contributors to extrinsic mortality, the environmental causes are driving natural selection. We have therefore evolved mechanisms to deal with things like this. There is a gradient going from catastrophic insult that affects all genotypes to mild challenges that just affect a few genotypes. That evokes that first explanatory gene by environment slide. They include infections, dysbiosis, starvation, malnutrition, dehydration, hypoxia, hyper and hypothermia, mechanical injuries, and exposure to venoms, toxins, and pollutants. So here's a case of starvation. This is a survivor of the Andersonville concentration camp in the U.S. Civil War. As technology and culture reduce the prevalence of these kinds of diseases, they then increase the prevalence of the next category, Category 3 diseases. Category 3 diseases are byproducts of defense systems. They result from the cost of defense, from deficient and excessive defense, and from malfunctions of defense systems. So these are vulnerabilities often exposed by environmental mismatches. Many of them are ultimately caused evolutionarily by a conflict between survival and reproduction on the one hand and health and well-being on the other. Their prevalence has increased as that of the Category 2 environmental diseases has declined, and they include immunopathologies, autoimmune diseases, asthma, fibrosis, metaplasia, hemodynamic and thromboembolic diseases, obsessive-compulsive disorder, phobias, paranoia, anxiety, and panic disorders. All these can be seen as byproducts of defense systems. Then there are the diseases of homeostasis. They affect physiological systems that are designed to be plastic and adjustable. And this design intrinsically makes them vulnerable to dysregulation. In part, they result from inappropriate adjustment of homeostatic set points. So homeostasis and plasticity both enable diseases when the system is set and locked in the wrong state. They include obesity, as the figure indicates, type 2 diabetes, atherosclerosis, hypertension, other cardiovascular diseases, and addictive behavior. They are often exposed by environmental mismatches. Category 5 diseases are diseases of maintenance. These are diseases that are not caused by the presence of some insult, but by the absence of maintenance. The decline of maintenance over time causes diseases of aging, here evoked by the contrast between a healthy brain and the brain of someone with severe Alzheimer's disease. The diseases of aging affect structures and processes that are most in need of maintenance and most costly to maintain. These diseases are mediated by antagonistic pleiotropy if we focus on genetic causes, and on trade-offs if we focus on physiological causes. They increase in frequency when a drop in extrinsic mortality extends lifespan. So this is one of the consequences of self-domestication. We extend lifespan and diseases of maintenance start to appear because our bodies were not designed to keep us well maintained that long. Maintenance processes can prevent these diseases, but there are no mechanisms in place to cure them once they begin. So they can be prevented naturally, but they cannot be cured naturally. They include neurodegeneration, sarcopenia, age-related cancers, type 2 diabetes, and arthritis. Category 6 diseases are caused by stochastic developmental problems. They're either too rare or they're too expensive for evolution to fix. They include trisomy 18 and 21, fetal hydrops, diseases of premature delivery, neonatal respiratory distress, necrotizing colitis, jaundice, and sudden infant death syndrome, SIDS. Most diseases in this category are prevented by oocytic attrition and early spontaneous abortions, which are the evolved quality control filters. Some, like preeclampsia, have complex causes, and they also belong in Category 7. So Category 7 includes diseases that are caused by disruptions of equilibria in conflicts between relatives. These include diseases of pregnancy, such as preeclampsia and gestational diabetes, of early development, including abnormal birth weights and gestation times, and of blood group incompatibilities. They may also contribute to, but they're not solely responsible for, the causation of mental disorders that include autism and schizophrenia, something we'll return to when we discuss mental disorders. Now, diseases can be viewed from 4 perspectives. The first is the patient's perspective. A disease is a state of not feeling well. There's pain, nausea, fatigue, discomfort, and depression. The physician's perspective is that a disease consists of abnormal conditions that produce symptoms compromising patient health, whose causes are then sought so that they can be corrected. The evolutionary perspective of a pathogen is that a disease can produce symptoms in the host that promote its reproduction or transmission, or they can be unintended byproducts of its interaction with the host. The evolutionary perspective of the host is that a disease can be a byproduct of prior natural selection. It can be a substrate for current natural selection via effects on reproductive success, or it can be a defense mechanism in action. So all diseases can be viewed from all four perspectives. All diseases also have both mechanistic and evolutionary explanations. They are not completely understood until both types of explanation have been given. For example, Crohn's disease, which presents with abdominal pain, diarrhea, and weight loss. A mechanistic explanation would use the language of genetics development, the biochemistry of NOD receptors, regulatory T cells, and the anti-inflammatory cytokine IL-10. An evolutionary explanation would talk about mismatch caused by modern hygiene leading to dysbiosis of a perturbed microbiota, focusing probably on a lack of worms. Both types of explanation contain clues for treatment, and we can't really see why the disease exists the way it does until we have worked through both. Now, genetic and environmental causes of disease are each of two types. Genetic causes can be defects or predispositions. So defects are the category 1 diseases, such as cystic fibrosis. Predispositions, on the other hand, are often polygenic rather than monogenic and are involved more often in environmental interactions. Environmental causes can be either catastrophic or accumulative. Catastrophes include predator attacks and infections with highly virulent pathogens like SARS, MERS, Ebola. Accumulative effects occur with things like smoking, overeating, and lack of exercise, which affect risks of cardiovascular disease, cancer, and type 2 diabetes. So the differentiation between sudden large effects and then continued smaller accumulative effects is important both for genes and for the environment. Here is an example of an accumulative environmental effect. What you see here is the risk, the adjusted odds ratio over here on the y-axis of developing peripheral arterial disease as a function of the amount of secondhand smoke encountered in the environment. So this is hours of exposure per week to secondhand smoke. And you can see that up to about 20 hours a week, it's not making too much difference. But from that point on, it climbs, and it's actually climbing exponentially. So it's curving upward on a regular graph. This is an exponential axis over here. And increased exposure to secondhand smoke is causing increased risk of peripheral arterial disease. That is a standard kind of accumulative environmental effect. Many of the genetic effects on disease are in fact mediated by interactions with the environment. And we refer to that as G by E, gene by environment, causation. Now, when a disease is caused by an interaction, it is a mistake to assign responsibility to just one component of the interaction. The important effects are actually tied up in the interaction. So, the environmental risks of cancer, such as tobacco and air pollution, depend on genotype. To see that, let's revisit the example of variation in N-acetyltransferase that we saw in a previous lecture. A good example of the interactions of genes and environment in determining disease risk is that of the N-acetyltransferases and cancer risk. We saw that with bladder cancer, where those with a combination of the NAT2 slow acetylator, the NAT1 fast acetylator, and current or ever cigarette smoking were 2.7 times more likely to get bladder cancer. For colorectal cancer, smoking intensity increased cancer risk among carriers of both NAT1 and NAT2 fast acetylators. much more than in those who did not have those. And for pancreatic cancer, the NAT1 polymorphism interacts with dietary mutagen intake, for example, barbecued meat, to increase the risk of pancreatic cancer 2.5 times in men, but not in women. So to evoke those associations, here we have smoking associated with colon cancer and barbecuing associated with these light liver metastases coming from the pancreas, visualized here against the darker red background of the sectioned liver. To summarize, we place diseases into 7 categories that have both mechanical and evolutionary causes. Genetic causes can act either catastrophically or through predispositions. Environmental causation can act either catastrophically or through accumulative effects. Many diseases result from G by E interactions that are missing in the classical disease categories. Important G by E interactions often occur when genetic effects are polygenic and environmental effects are accumulative. And depending on the causation, organisms either evolve defense mechanisms to protect themselves against the disease, maintenance mechanisms to help prevent disease, or in some cases, no such mechanisms at all.